Hello, my name is Matthew Egbert. I'm a senior lecturer at the School of Computer Science at the University of Auckland. And it's a pleasure to be here and have a chance to introduce myself and talk about my trajectory as an A-Life researcher. The first question I was asked to respond to is what sparked my interest in A-Life research and how I got started in the field. And my first exposure to A-Life was at a presentation as an undergraduate. I was a student in computer science at St. Andrews University in Scotland. And Tim Taylor actually came along and gave a presentation to our department. And that presentation included the super inspiring video of Carl Sims' Virtual Creatures, which I know has inspired many people in A-Life to pursue a career in artificial life research. I saw that video and I was just amazed at the lifelike dynamics of the simulated creatures that were produced by an artificial evolution process. And I remembered it. It was truly inspiring. But then I finished my degree in computer science and I went and worked in industry for a few years, developing websites and doing some software consulting. And eventually realizing that really wasn't for me. I wanted to be a researcher. I enjoyed programming. I didn't love software engineering. I felt like I was doing the same thing over and over again at some level as a software engineer. And so I wanted to be in a line of work where I was faced with questions that people hadn't answered before, and where I felt like I could really contribute and do something new and push the sort of the boundaries of human knowledge, to put it slightly dramatically. And at that point, I looked around. I was trying to figure out how could I do that. And I remembered this talk that Tim Taylor gave, and I remembered how cool that was. And I was like, what is that? And I did some looking around. I found the video again, found out that the field was called artificial life. And then I looked for the best programs to study artificial life that were around at that time in the world. And at the top of the list was a program at the University of Sussex called the Evolutionary and Adaptive Systems Master's Program. And I went and studied there for a year as a mature student, in the sense that I'd been working in industry for a few years. And it was such a great pleasure to go back and be a university student again. I had a great year there for a year. And I don't know, a few months in, I was pretty confident that I wanted to stay there and do a PhD. And I was really lucky to find a scholarship there, and to, at that point, be inspired by some really great thinkers. Inman Harvey was there, Ezekiel DePaula was there at the time, and they both really impressed me with their ability to go to a talk on virtually any subject and have really incisive questions and comments about the talk. And I just thought, man, these are smart fellows, and I really wanted to have that skill and to develop that skill of being able to think really critically about what I'm being told, to have an open mind as well. They introduced me to ways of thinking about life and mind that were just truly inspiring. So a big thank you to them for being so influential on my career. Yeah, and then I did the postdoc circuit for a while. I did sort of 3 years of postdocing before finally finding this position here at the University of Auckland, where I'm trying to sort of continue studying some of the topics that came up during my PhD, which I think actually links quite nicely to the second question, which is, can you explain one of your most exciting or surprising findings in the field of artificial life in a way that a beginner could understand? To explain this, I think that the best thing to do is to show you a video, which is of a model that I developed when I was a PhD student. At the time, I was interested in life and what life is. I was particularly interested in this idea that living systems are systems that are falling apart all of the time, but are rebuilding themselves. So in biology, this property is often referred to as metabolism, where every living system is taking energy and material from the environment and using that energy and material to rebuild and repair itself. And I just think that's an amazing property. And I was curious sort of what the ramifications of it are. At Sussex, there was a bit of a sort of rebellious philosophy in a lot of the science of people are looking at things in this one way. So, for example, people are looking at life in terms of evolution. And here was this other property of life which didn't seem to have as much attention, this metabolic property. And so, inspired a little bit by the rebelliousness of Sussex, I wanted to also sort of take this slightly different perspective at trying to understand what life is and studying it. And I wanted to understand metabolism and what does the fact that living systems are falling apart all the time and yet rebuilding themselves, what can we learn from that? How can it inspire us to build new technology? The third and final question I've been asked to address is, what is one big unanswered question in artificial life that you think could be important in the future? I brought up this model, and I mentioned that so much of my research has sort of followed on from this idea of relating metabolism and behavior. At some level, that's one big question that still motivates me. There's a lot of focus on life, focuses on evolution and its dynamics, but there's many other parts of life that are just as amazing to me as the fact that just as amazing as evolution is. For instance, the fact that living systems appear to act purposefully, the fact that living systems such as ourselves have a perceptual experience, which is to say there's something that it's like for me to sit here and record this presentation. There's something that it's like for you to sit or stand or lie there listening to this presentation. We have an experience. We have, what people sometimes talk about as consciousness. We have something that it's like to be us. And all of the examples that we have of that, well, the only example that any one of us has of that we're 100% certain about is true is our own experience. But the other examples that most of us believe are valid of having this perceptual experience are other people, and indeed other animals, perhaps, and perhaps even other organisms that are not animals. There's talk about plant consciousness and so on. And this is, of course, a huge open question, and it's been an open question for thousands of years of what are our minds? What does it mean to be a thinking, acting being with desires, with goals that come from the inside rather than those that are given to us? And how do these relate to being a living organism? All of these examples that we have of systems that we think are or even might be conscious or have a perceptual experience and so on are living systems. And so does that mean that a system needs to be alive to be able to have these mental phenomena that I'm enumerating here, that I'm listing? And I think that some of this computational modeling that we do in A-Life is well suited to helping us think better about these kinds of questions. People build computational models of neurons that are either realistic or unrealistic, but do solve problems well. So a lot of AI research is really doing well right now and making very impressive tools for solving problems that are really fantastic advances. But I don't feel like those advances are addressing these questions that I've raised about what does it mean to be a thinking, living, experiencing being. And it's a question that I think inspires many of us in this field, and is clearly an open one too. So I'll end there, I think. I hope that you found this interesting. If you are interested in pursuing further studies in this area, then by all means get in touch. I'm a lecturer in the computer science department at the University of Auckland, and often looking for graduate students who are interested in these areas. So thanks for watching, and thank you.